The 1950s were a decade of revolution in American agriculture. While most farmers stuck to familiar iron, a handful of manufacturers dared to build machines so advanced, so unusual, or so perfectly specialized that they never made it past the experimental stage or limited production runs. Today, we're counting down the 10 rarest harvesters out of the 1950s, machines that changed everything, yet almost disappeared from history entirely. From experimental prototypes to forgotten masterpieces of engineering, these are the combines and harvesters that collectors hunt for and historians dream about. Number 10, the 1954 Allis-Chalmers All-Crop 66, self-propelled. Standing at number 10 is a machine that represented Allis-Chalmers' bold gamble on compact efficiency. The 1954 All-Crop 66 self-propelled harvester wasn't just rare because of limited production numbers. It was rare because it arrived at exactly the wrong moment in agricultural history. Farmers were supersizing everything, chasing bigger grain tanks and wider cutting platforms. Yet here came Allis-Chalmers with a nimble, lightweight machine designed for small to mid-sized operations and specialty crops. Only a few hundred units rolled off the line before the company shifted focus to larger models, making survivors incredibly scarce today. The All-Crop 66 featured a 66-inch cutting width, which sounds modest by modern standards, but was perfectly suited for the rolling hills and tight field corners of Appalachian and northeastern farms. Powered by a 4-cylinder gasoline engine producing around 40 horsepower, this harvester was never going to win any drag races, but it delivered something more valuable: reliability and versatility. The engine breathed through a simple carburetor system that farmers could actually service themselves without calling a factory technician, and the powertrain was built with heavy cast iron components that could take decades of punishment. What made the All-Crop 66 truly special was its adaptability. Allis-Chalmers designed this machine with a quick-change header system that allowed operators to switch from grain harvesting to corn picking or even bean cutting with minimal downtime. The grain tank held approximately 35 bushels, which meant frequent unloading, but also kept the machine light enough to work wet fields without sinking. The unloading auger could swing out to either side, a feature that seems basic now, but was genuinely innovative in the early 50s, when most combines required precise positioning next to grain trucks. The ride quality on the 66 was surprisingly civilized for its era. Allis-Chalmers fitted a sprung seat that actually absorbed some of the pounding from rough fields, and the controls were laid out in a logical pattern that didn't require constant contortion. The steering was heavy, sure, but responsive enough to navigate tight headlands without multiple point turns. Visibility from the operator's station was excellent, with the engine positioned low and to the right, giving a clear view of the cutting platform and the crop flow into the feeder house. Production ended after just 3 seasons, making intact examples almost mythical today. Most were worked until complete exhaustion, then parted out or left to rust in fence rows. The few that survive command serious money at farm auctions, not because they were the biggest or the fastest, but because they represented an alternate vision of what harvesting could be: precise, manageable, and built for the farmer who valued craftsmanship over sheer capacity. The Allis-Chalmers All-Crop 66 reminds us that bigger wasn't always better, and that some of the rarest machines are rare because they were simply ahead of their time in ways the market wasn't ready to appreciate. Number 9, the 1953 Massey-Harris 90 self-propelled prototype. Designed to outpace the competition with features years ahead of their time, fewer than 15 pilot units were ever built. Massey-Harris tested them across Midwestern farms before deciding the machine was too sophisticated and costly for the early 50s market. Today, only a handful survive, mostly in private collections or overlooked museum corners. The 90 name came from its 90-inch cutting width, putting it on par with top combines from International Harvester and John Deere. But that's where similarities ended. Massey-Harris engineers gave it a 6-cylinder engine with an overhead valve design, delivering nearly 70 horsepower, impressive for a mid-size harvester of its era. This layout improved fuel economy and reduced overheating, solving key issues that plagued early self-propelled machines. More than power, the 90 stood out for its grain handling system. Instead of the traditional paddle-type threshing cylinder, it used a rasp bar cylinder, gentler on kernels, with less cracking and higher quality samples. An adjustable concave system let operators fine-tune threshing clearance from the cab without stopping the machine. 3 aggressive rotating straw walkers handled separation, maximizing grain recovery from the chaff. Its 50-bushel grain tank was standard for the time, but the unloading system was revolutionary. Massey-Harris added a hydraulic auger that could extend and retract at the push of a lever. Unloading speed nearly doubled compared to conventional setups, and a dedicated hydraulic pump with accumulator ensured consistent performance under load, an uncommon feature back then. Test operators praised its smooth performance in ideal conditions, but the machine struggled in dense or green-stemmed crops. The Rarest bar cylinder could clog, and the hydraulic system required skills most farmers didn't yet have. With no production parts support, one broken component could sideline the machine permanently. Visually, the 90 reflected the design optimism of the era. Smooth bodywork, red and cream two-tone paint, and chrome accents. The cab had a padded seat and a folding sun canopy, features considered luxurious in a decade when comfort was secondary to function. But with most farmers still paying cash, the projected price proved too steep for wide adoption. Though abandoned before full production, the 90's features resurfaced in later Massey-Ferguson machines after the company's merger. Today, it remains one of the rarest and most innovative harvesters ever built, a bold vision of the future that arrived too soon for its time. Number 8, the 1957 Minneapolis-Moline Uni harvester. At number 8 is one of the boldest experiments in harvesting history, the 1957 Minneapolis-Moline Uni harvester, a machine designed to do everything with one platform. It aimed to harvest grain, corn, hay, and more through quick swap attachments. On paper, it was revolutionary. In reality, it was a maintenance-heavy gamble that proved too complex for most farms. Fewer than 200 units were built before the line was discontinued, making surviving examples extremely rare. The Uni harvester ran on a Minneapolis-Moline 4-cylinder gasoline engine displacing 206 cubic inches and generating about 55 horsepower. That was sufficient for its weight, but the real innovation lay in the drivetrain. It featured a modular power takeoff system, capable of routing power to various attachments mounted on the front. A 4-speed transmission with a stiff hand clutch made for a tough ride, both mechanically and physically. At the heart of the concept was a universal mounting frame at the front. This system used hydraulic quick couplers to connect a wide range of implements: a 72-inch grain header, a 2-row corn head, a sickle bar mower, and even an experimental cotton picker. In theory, this let farmers handle multiple crops with one machine. In practice, each attachment swap was laborious, requiring precise alignment and usually an hour or more of setup time. The added complexity raised the machine's center of gravity, making it unstable on uneven ground. The grain tank held only 40 bushels, smaller than average even for the time, as weight distribution had to account for the front-mounted hardware. Still, the conventional threshing system, with a Rarest bar cylinder and straw walkers, performed well, delivering clean samples of wheat, oats, or barley. Once dialed in, the machine could operate smoothly. The hydraulic system used a gear-type pump strong enough to run multiple components at once. The unloading auger swung across a 180-degree arc, helping fill grain trucks on the move. The corn head was effective in upright crops, but struggled in tangled fields. The styling was industrial: square body lines, a gray and yellow color scheme, and an open operator station with only an umbrella for sun cover. The seat was little more than a spring-mounted tractor saddle, offering a rough ride. Gauges were basic, and the fuel gauge was notoriously inaccurate. Ultimately, poor parts availability doomed the Uni harvester. With few units sold, support never materialized. Most machines were scrapped or converted by the early 60s. Yet today, surviving platforms, especially with multiple attachments, are prized collector's items. The Uni harvester was a brilliant misfire that proved even smart ideas need timing, simplicity, and support to succeed. Number 7, the 1951 Oliver 66 Pull-Type Hillside Leveling Combine. Sliding into number 7 is a machine that solved a problem most farmers never anticipated. The 1951 Oliver 66 Pull-Type Hillside Leveling Combine was engineered specifically for the steep, uneven terrain of the Pacific Northwest and the Palouse region. Standard combines lost grain or risked tipping when crossing slopes, but the Oliver 66 featured a pioneering self-leveling system that kept its threshing components level, even when the machine tilted sharply. Fewer than 300 were built, and since they worked in some of the toughest terrain in North America, surviving units are exceptionally rare. The leveling system was mechanical ingenuity at its peak. The entire threshing unit, including the cylinder, concaves, straw walkers, and cleaning shoe, was mounted on a pivoting frame. A pendulum-controlled hydraulic valve sensed slope and automatically shifted the assembly to remain level. This passive automation required no operator input and allowed the machine to handle inclines up to 20 degrees, a feat that made it one of the most capable hillside harvesters of its time. The combine relied on the pulling tractor for power, typically a machine producing at least 45 horsepower. A power takeoff shaft drove the combine's threshing cylinder via belts and pulleys that demanded regular maintenance. The 66-inch wide cylinder spun at around 550 revolutions per minute, slower than some competitors, but paired with aggressive rasp bars for efficient threshing in hard wheat varieties. Its 38-bushel grain tank was intentionally modest to maintain a low center of gravity for slope stability. The unloading system was a basic spout, requiring precise positioning of a grain wagon or bagging station. Oliver chose not to add a hydraulic auger to keep complexity and costs down for its target market. Traction was another area where the 66 excelled. It used wide-set main wheels with optional chevron pattern tires for grip on steep slopes. Weight distribution kept the combine tracking steadily behind the tractor, while the header's flexible skid shoes followed ground contours without digging in, essential for navigating abrupt elevation changes. While operators praised its hillside performance, they often struggled with the leveling system. When functioning, it was near miraculous, but breakdowns were difficult to diagnose, and replacement parts were rarely stocked by local dealers. Some machines were eventually converted to fixed frame setups, sacrificing their greatest advantage just to keep running. Painted in Oliver green with cream accents, the 66 was robustly built, with thick steel framing and industrial-grade components. It was clearly engineered for rugged use. Today, collectors value it not for speed or size, but for its problem-solving brilliance. The Oliver 66 proved mechanical solutions could revolutionize farming, even if only a few farmers ever got to use one. Number 6. The 1955 Case Model SC Pull-Type Rice Combine. At number 6, we enter the specialized world of rice harvesting with the 1955 Case Model SC, a pull-type combine built for one purpose: thriving in the wet, unforgiving rice fields of the American South and West. Traditional grain combines couldn't cope with saturated soils, heavy straw, or the precision needed for high-quality rice threshing. Case responded with a machine tailored for the job. Fewer than 400 were produced, making it a rare find today, even in the Rice Belt. The Model SC rode on a rugged steel frame designed to handle mud and moisture. Its wide main wheels could be outfitted with flotation tires or cage wheels to prevent sinking in deep paddies. Up front, the 84-inch cutting platform featured a serrated sickle bar designed to slice through dense, wet straw without clogging. An adjustable reel helped feed material evenly into the feeder housing, crucial in variable field conditions. Power came from the towing tractor, and Case recommended at least 50 horsepower to manage the heavy threshing load. The PTO shaft was reinforced with breakaway couplings and safety shielding to protect the drivetrain if the cylinder jammed. The cylinder itself used rubber-faced rasp bars, a unique choice that delivered aggressive threshing while preserving kernel quality, critical for maintaining milling value. Separation was handled by extended straw walkers with tight slats, optimized to release rice from sticky straw. The cleaning system used a 3-sieve shoe and a high-velocity radial fan designed to blow chaff clear of heavier grains. The grain tank held 42 bushels, a practical size given that rice harvesting involves frequent unloading due to high moisture content. One of the SC's standout features was its variable speed cylinder system. Using a hand-operated lever and pulley, operators could adjust belt tension and change threshing speed between 400 and 700 revolutions per minute, depending on crop variety and moisture levels. This flexibility was rare in mid-50s combines and proved invaluable in rice-specific conditions. Build quality was classic Case, overbuilt and meant to last. The frame used thick channel iron with reinforced stress points. Bearings were sealed to withstand water, abrasive straw, and long operating hours. Finished in flambeau red with desert sand accents, the machine came with decals that included detailed operation instructions, helping seasonal crews learn the system quickly. Rice growers praised the SC for reliability and performance in conditions that halted ordinary combines. The only drawback was its lack of a hydraulic unloading auger, requiring bagging or carefully placed wagons. By the late 50s, Case shifted to self-propelled models, rendering the SC obsolete. Most were used until failure, and intact survivors today are prized as museum-level relics of specialized American farm engineering. Number 5. The 1956 Co-op. Number 3. Self-propelled experimental. Breaking into the top 5 is one of the most unusual stories in harvester history. The 1956 Co-op Number 3, an experimental self-propelled combine built by America's agricultural cooperatives. These groups had already been selling tractors under the Co-op brand, but the Number 3 marked their ambitious attempt to design and manufacture a combine of their own. Partnering with a small Midwestern firm, they produced fewer than 50 machines. Only about a dozen are believed to survive today, making it one of the rarest harvesters of the entire decade. The Number 3 was powered by a Chrysler 6-cylinder flathead gasoline engine, producing 72 horsepower. While the flathead design was outdated by 1956 standards, it was reliable, easy to maintain, and widely available at a reasonable cost. The engine used a single carburetor and simple ignition system that could be serviced by any farm mechanic. A 25-gallon fuel tank provided enough runtime for most daily operations. Its 78-inch cutting platform used a conventional sickle bar and a bat-style reel for crop feeding. The header could be raised or lowered hydraulically, one of the few modern features on an otherwise traditional build. The feeder house was steep and wide, feeding material into a 72-inch rasp bar cylinder, spinning at 600 revolutions per minute. This setup offered solid threshing performance in wheat, oats, and barley. What truly set the Number 3 apart was its maintenance philosophy. It was built for farmers to repair themselves without needing dealer support or special tools. The threshing system used traditional straw walkers with adjustable spacing, and the cleaning shoe featured simple sieves that could be swapped for different crops. The grain tank held 45 bushels and unloaded through a mechanical auger, powered by a small gasoline engine mounted directly on the auger, a quirky solution that avoided complex routing, but added another engine to maintain. The operator's station was extremely basic. It had a stiff spring seat, a simple steering wheel connected through a mechanical box, and a flat metal dashboard with minimal gauges. There was no cab, no sound insulation, and no weather protection. Pedals were awkwardly placed, forcing constant shifting and stretching. The machine was painted in a bold harvest gold, with white accents and prominent Co-op logos on each side. It had a rugged utilitarian look, more about function than flair. Field performance was solid but unrefined. The engine delivered reliable power, and the mechanical layout made repairs simple. However, grain samples showed higher levels of cracking and chaff than those from competitors. Ultimately, high development costs and a lack of parts support ended the project, but the surviving machines remain powerful symbols of cooperative independence and alternative thinking in American agriculture. Number 4. The 1952 International Harvester Model 61, Pull-Type Hillside Special. Claiming the number 4 position is International Harvester's answer to slope-specific harvesting. The 1952 Model 61 Pull-Type Hillside Special was built for farmers working steep terrain in regions like the Palouse, Appalachia, and the Alleghenies. Unlike Oliver's leveling system, International Harvester kept things mechanical and simple. A wide stance and ultra-low center of gravity replaced complex hydraulics. With fewer than 350 units produced, most sold through select regional dealers, surviving machines are now extremely hard to find. The 61 started with IH's standard pull-type combine platform, but was heavily modified for hillside conditions. The main wheels were spaced 5 feet apart, and the frame rode low to maximize stability. A 72-inch cutting platform with flexible skid shoes helped maintain even cutting height on uneven terrain. The chain-driven reel was set forward, allowing it to gather downhill-leaning crops more effectively. Because of the heavy-duty frame and wider cylinder, IH recommended a tractor with at least 50 horsepower, though many operators used 60 horsepower units for safety and ease. The PTO shaft was reinforced with a slip clutch to prevent damage from sudden shock loads. Threshing was handled by a 72-inch rasp bar cylinder, spinning at 600 revolutions per minute, offering solid efficiency across small grains without excessive cracking. To improve grain retention on sloped ground, the separation system featured 4 straw walkers, one more than standard models, and a wider cleaning shoe, fitted with internal baffles to prevent grain from bunching or sliding to one side. The chaffer and sieve could be adjusted from the back of the machine with hand levers, and a centrifugal fan provided adjustable airflow tailored to crop type and field condition. The grain tank held 40 bushels, modest by design to preserve the combine's low center of gravity. Unloading was handled by a gravity spout, rotatable to either side. There was no powered auger, a decision made to reduce both weight and complexity. One rare feature on the 61 was its operator-controlled braking system. Each main wheel had a drum brake that could be activated from the tractor, letting the operator manage the combine's tracking when descending hills. This helped prevent the combine from pushing forward uncontrollably, an essential safeguard on steep grades. Built from thick steel channel with sealed bearings and quality V-belts, the 61 was durable and over-engineered, as was IH tradition. It wore red paint with cream accents and bore hillside special decals proudly. Production ended in the mid-50s with the rise of self-propelled hillside models. Still, the Model 61 earned loyalty from operators who valued safety, control, and grain quality above all else. Today, it stands as a rare symbol of practical design for extreme terrain. Number 3, the 1959 Gleaner Model L experimental turbine drive. Landing at number 3 is a machine so far ahead of its time that even today the industry hasn't fully caught up. The 1959 Gleaner Model L experimental turbine drive was Allis-Chalmers' attempt to bring turbine power to agriculture. While the standard Model L became a successful production machine, the turbine-powered version was purely experimental. Only 3 prototypes were built, and 2 are known to survive, making it one of the rarest combine variants ever developed. The turbine engine produced around 80 horsepower and offered several advantages. It was lightweight, reducing frame stress and improving balance. It operated smoothly without the vibration of a piston engine, creating a quieter and more comfortable experience for the operator. Throttle response was instant, with smooth power delivery and no torque fluctuation under load. The turbine could also run on multiple fuels: gasoline, diesel, kerosene, or jet fuel, offering flexibility in the field. However, the drawbacks were serious. Fuel consumption was nearly double that of standard engines, so the 40-gallon tank had to be upgraded to 60 gallons. Turbines needed exceptionally clean air to avoid blade damage, so Allis-Chalmers installed a multi-stage filtration system. Even with those precautions, dust ingestion remained a threat, and while smoother in tone, the turbine's high-pitched whine was unpleasant to many operators. Mechanically, the layout was complex. The turbine, mounted low behind the operator's station, spun at roughly 25,000 revolutions per minute. A reduction gearbox brought that down to usable speeds for threshing and auxiliary systems. The gearbox used helical cut gears in an oil bath, keeping temperatures low and noise manageable. The drivetrain ran cooler and required less maintenance, but was expensive to manufacture. The cutting platform was 96 inches wide, with hydraulic motors replacing belts for the header drive. This allowed operators to adjust reel and cutter speed on the fly, a feature years ahead of its time. The threshing system used Gleaner's proven transverse cylinder with rasp bars, straw walkers, and a cleaning shoe with adjustable sieves. The 65-bushel grain tank and hydraulic unloading auger made unloading fast and efficient, powered by a dedicated hydraulic pump driven off the turbine. In testing, the machine performed well in clean conditions. The smooth, vibration-free operation reduced fatigue, and the turbine responded well under load. But dusty fields overwhelmed the filtration system, and once damaged, turbine blades required full engine replacement, far beyond what field technicians could handle. Ultimately, cost doomed the project. The turbine engine cost over 3 times more than a piston engine, and high fuel consumption erased efficiency gains. The idea was shelved, but the surviving machines remain icons of mid-century agricultural innovation. Fascinating, impractical, and unforgettable. Number 2, the 1951 Avery Model 500 self-propelled. Surging into the number 2 spot is a machine that represents one of agriculture's greatest what-if moments. The 1951 Avery Model 500 self-propelled combine was the final effort from a company that had once dominated the threshing industry during the steam era. As Avery faced bankruptcy, they bet everything on a revolutionary design, one that pushed technological boundaries far beyond anything else on the market. They managed to build just 65 production units before the company closed its doors forever. Today, perhaps 8 or 9 remain, making it not only one of the rarest harvesters of the decade, but also one of the most historically significant. The Model 500 was powered by an Avery-built 6-cylinder gasoline engine, displacing 339 cubic inches, delivering 85 horsepower, an exceptional figure for 1951. The engine used overhead valves, a progressive design choice that improved airflow and combustion efficiency. A massive radiator and thermostatically controlled fan kept it cool even during long harvest days in extreme heat. But the real innovation lay in its hydrostatic drive system. Instead of gears and clutches, Avery used a hydraulic pump and motor setup that allowed for infinitely variable speed, all controlled through a simple lever. Push forward to accelerate, pull back to slow, no shifting or clutching required. This was technology decades ahead of its time, and Avery had it working reliably in the early 50s. It gave unmatched control, letting the operator adjust ground speed instantly to crop conditions, something no other machine of the era could offer. The cutting platform spanned a full 100 inches, among the widest of its time. Avery replaced the common bat reel or draper with a full-fingered auger, which fed crop evenly without bunching. Cutting height could be adjusted on the go using a conveniently located hand crank, and the sickle bar used Avery's own guard design with long-lasting serrated edges. Threshing was equally advanced. A 100-inch rasp bar cylinder handled heavy crop volumes with ease, and the variable pitch pulley system let operators fine-tune speed for different moisture levels or grain types. Sectional concaves allowed damaged areas to be replaced individually, a rare level of serviceability. 5 wide straw walkers separated grain efficiently, feeding a triple sieve cleaning chute paired with a high-capacity centrifugal fan. It kept samples clean and minimized losses. The 70-bushel grain tank was one of the largest of its time. Unloading was handled by a hydraulically driven auger with telescopic extension, allowing unloading into trucks without needing perfect positioning. Again, Avery offered features that wouldn't be standard elsewhere for decades. The operator's station was a glimpse into the future. It featured a padded suspension seat, a wraparound console with clearly labeled controls, and full instrumentation, including ground speed, oil pressure, and even grain tank level. A fold-down canopy offered sun protection, giving operators a level of comfort rare for the era. Styling matched the engineering. The combine wore Avery's two-tone Harvest Ivory and Avery Green paint scheme, accented with chrome and flowing script logos. It looked as modern as it functioned, a symbol of forward-thinking craftsmanship. Farmers who bought the 500 loved it. It worked fast, ran smoothly, and produced excellent grain quality. But Avery's financial collapse left owners without parts, service, or support. Many machines were parked or scrapped despite their performance. The few that survive are maintained by dedicated collectors who recognize what the Model 500 was, a technological masterpiece that arrived too soon, built by a company that dreamed big but couldn't outlast its own ambition. Number 1. The 1958 Farmall Combination Harvester Windrower Prototype. Taking the top spot as the rarest harvester out of the 1950s is a machine that almost nobody has ever heard of. Yet, it represented one of the most ambitious engineering projects International Harvester ever attempted. The 1958 Farmall Combination Harvester Windrower Prototype was designed to revolutionize small grain harvesting by combining 2 operations into a single pass. Instead of cutting and windrowing grain in one operation, and then picking up and threshing the windrows days later with a separate machine, this revolutionary design would cut, thresh, and windrow the straw all in one continuous operation. International Harvester built exactly 7 prototype units for field testing across different regions and crop types. Today, only 2 are known to exist, both in private hands, making this the absolute rarest harvester of the decade. The engineering challenge was immense. Traditional combines threshed the crop and scattered the straw across the field, which was fine if you were grazing livestock or leaving organic matter for soil health. But many operations wanted to bale the straw for bedding or sale, which meant windrowing the material neatly behind the combine. IH's solution was to route the cleaned straw from the separation system through a conditioning system and then deposit it in a uniform windrow directly behind the machine. This required a complete redesign of the rear end of the combine and the addition of conditioning rolls that would crimp the straw to accelerate drying. The prototype was built on a modified Farmall self-propelled combine platform, powered by an International Harvester 6-cylinder gasoline engine producing 90 horsepower. This was substantial power, necessary because the additional straw handling equipment added significant load to the drivetrain. The engine featured overhead valves and a heavy-duty cooling system with an oil cooler to manage the increased heat from sustained high-load operation. Fuel capacity was 45 gallons, which gave a reasonable operating range despite the high power demands. The cutting platform was 90 inches wide and used conventional sickle bar design with a pickup-style reel that was particularly effective at gathering crop that was partially lodged or leaning. The header fed into a wide feeder house that directed the crop stream into a Rarest bar cylinder, running at variable speeds from 450 to 700 revolutions per minute. The cylinder was 90 inches long and used replaceable Rarest bars that could be configured for aggressive threshing in dry conditions or gentle handling in damp grain. After threshing, the grain and straw separated in a conventional straw walker system. But here's where the design diverged dramatically from standard combines. Instead of the straw walkers depositing material onto the ground through a spreader, they fed into a pair of heavy-duty conditioning rolls. These rolls were spring-loaded steel cylinders with raised chevron patterns that crimped and crushed the straw stems, breaking the waxy outer coating and allowing faster moisture loss. The conditioning intensity could be adjusted by changing the spring tension, giving operators control over how aggressively the straw was processed. From the conditioning rolls, the straw was directed onto a wide canvas conveyor that ran the length of the machine and deposited the material in a neat windrow about 4 feet wide directly behind the combine. The windrow was consistent and uniform, perfect for later pickup by a baler. The system worked brilliantly in theory and pretty well in practice, though it required constant attention to canvas tension and roll clearance to prevent plugging. The grain handling was conventional but well executed. The cleaning shoe used a 3-sieve system with a powerful fan that could be adjusted for different crop conditions. The grain tank held 55 bushels, which was a compromise between capacity and weight distribution given all the additional equipment at the rear of the machine. The unloading auger was hydraulically driven and could swing through a wide arc, making unloading into moving grain trucks straightforward. The operator's station was comfortable by 1950s standards, with a suspension seat, full weather canopy, and comprehensive instrumentation. The control console included not just the standard combine controls, but also adjustments for conditioning roll pressure, windrow width, and straw conveyor speed. This gave the operator tremendous flexibility, but also added complexity that required training and experience to master. IH included a detailed instruction manual with each prototype, and factory representatives spent days with each test farmer explaining the proper operation and adjustment procedures. Field testing revealed both the promise and the problems with the combination harvester windrower concept. In ideal conditions with standing grain at proper moisture levels, the machine was impressive. It could harvest 40 to 50 acres per day, delivering clean grain to the tank and leaving perfect windrows ready for baling. The straw quality was excellent, with the conditioning process actually improving drying time compared to unconditioned windrows. Farmers who tested the prototypes were excited about the potential labor and time savings from combining operations. But problems emerged in less than ideal conditions. Green or damp straw would plug the conditioning rolls, requiring frequent stops for cleaning. Heavy crops with thick straw could overwhelm the conveyor system, causing uneven windrows or complete plugging. The additional weight and complexity reduced reliability compared to standard combines, and service requirements were higher because of all the moving parts in the straw handling system. Most seriously, the economics were challenging. The machine cost nearly 50% more than a standard combine, and the benefits only materialized for operations that wanted to bale straw, which was a minority of the market. International Harvester ultimately decided not to proceed with production. The market research showed that most farmers prefer the flexibility of separate harvesting and windrowing operations, even if it meant making 2 passes through the field. The combine market was trending toward larger, higher capacity machines, and adding straw conditioning equipment ran counter to that direction. IH shelved the project and redirected engineering resources toward conventional self-propelled combines that could compete on capacity and speed. The 7 prototypes were distributed to the test farms and to IH's experimental farm for continued evaluation. Most were eventually scrapped or parted out as IH moved on to other projects. The 2 survivors exist because far-sighted individuals recognize their historical significance and preserve them despite their limited practical utility. One is held in a museum collection in the Midwest, displayed but non-operational. The other is in a private collection and has been painstakingly restored to running condition, a tribute to both IH engineering and the dedication of the collector who refused to let this piece of history disappear. The 1958 Farmall combination harvester windrower prototype represents the road not taken in combine development It showed that complex multifunction machines were possible, but it also demonstrated that sometimes simpler is better. The concept would resurface decades later in different forms, with modern combines offering conditioning and windrowing attachments as options rather than integrated systems. But in 1958, it was too much, too soon, for a market that wasn't ready to pay the premium for integration. These 10 machines weren't just metal and rubber. They were America's rolling symbols of innovation, ambition, and the relentless drive to make farming more efficient. Some succeeded in their specialized roles, others failed spectacularly, but every single one pushed the boundaries of what harvesting equipment could do. Which of these rare machines would you most want to see running in the field one more time? Drop your thoughts in the comments and subscribe for more stories from the machines that fed a nation and shaped an industry.